Good morning, ladies and gentlemen. This is Mrs. Avila presenting your lesson for Monday, May 4th. This is for Rio Rancho Middle School Earth Science. Before we begin today's lesson, here's your week at a glance. Kind of lets you see what is coming up throughout the week. There's a meme there, cats trying to find a cure so humans will go back to work. I had another meme last week that kind of mentioned that what our pets must be thinking with us being at home so much. Okay, so today's lesson is going to be about learning more about past climate changes. And our essential question today is, how do carbon dioxide and methane affect energy entering or exiting the Earth system? Another meme of the day, may the 4th be with you. It's Baby Yoda with a face mask. All right, so what's the agenda for today? We're going to watch the Screencastify video that you're watching right now, going through the lesson. You're going to fill out the Learning More About Past Climate Changes document. You're going to copy and paste key concepts numbers 10 and 11 into the Unit 7 Key Concepts Chapters 2 and 3 document. You will need to have this Screencastify video open. Typo there, it's only one video today. The Learning More About Past Climate Changes document, and the Unit 7 Key Concepts Chapters 2 and 3 open. So it's telling you, excuse me, that's what I get for doing this at 3 in the morning. It's telling you what you need to have open. You're going to have those 3 tabs open today. Please make sure that you press Turn In for your Learning More About Past Climate Changes document. You're going to make sure you turn that in. Do not turn in the key concepts assignment. You will be working on this for a few more days, okay? All right, so getting into today's lesson, learning more about past climate changes. We have our essential question there again. How do carbon dioxide and methane affect energy entering or exiting the Earth system? Make sure that you have this document open and your key concepts, Earth-changing climate key concepts that you have been working on. Climate change is not a new thing. There is evidence that this has happened before in Earth's history. Today, you will use evidence from the text about warming during the Eocene period in order to model the Earth system during this current warming climate. We will also look at how cooling happened during the Cryogenian period. So remember that our unit question is, what causes climate? Our Chapter 2 question is, why do temperatures on Earth increase when the amount of carbon dioxide or methane in the Earth system increases? Earth's current climate is changing, but there have been other times in Earth's history when the climate changed. During some of these times in the past, more energy entered than exited the system. Last week, we read the article, Past Climate Changes on Earth. Using the information from the article, we need to answer this question today. How do carbon dioxide and methane affect energy entering or exiting the Earth system? So let's read again the section that describes what Earth was like during this period. So we're only going to read a couple of sections. So the first one is alligators in the Arctic, the Eocene period. About 56 million years ago, Earth's temperature rose suddenly. Earth got so warm that water in places that were normally very cold or even frozen, such as places near the Arctic Circle, became warm. During the Eocene period, landscapes near the poles looked like swamps in Florida, do today. Earth has no ice caps, and the water in the Arctic Ocean was warm enough for a pleasant swim. In fact, scientists have found fossils showing that alligators, which are warm water organisms, lived in the Arctic during the Eocene period. The global average temperature was about 16 degrees Celsius, which is about 28.8 degrees Fahrenheit, warmer than it is today. So that's a pretty big jump. This information The information contained in the article can answer two very important questions. The first question is, when more energy enters than exits the Earth system, what happens to the temperature on Earth? And the second question is, do carbon dioxide and methane affect energy entering or exiting the Earth system? So our answers, the answer to number one, if more energy enters than exits the Earth system, energy absorbed by the surface would increase, causing global average temperatures to increase. The article provides evidence that this happened during the Eocene period 56 million years ago. The answer to the second question, energy enters the Earth system from the sun and is absorbed by Earth's surface. Some energy leaves the Earth system by traveling back through the atmosphere and out to space. Carbon dioxide and methane affect energy exiting because they stop some outgoing energy from leaving the Earth system. When the amount of carbon dioxide or methane increases, the amount of energy leaving the Earth system decreases. Let me read that again. When the amount of carbon dioxide or methane increases, the amount of energy leaving the Earth system decreases. This means more energy enters than exits, causing global average temperature to increase. So in Amplify, they would have us put together these models, and we're trying to limit you guys having to go into Amplify because a lot of you are having problems. You could show that, if I can show all of this at once. The picture on the left is showing before the change, where the temperature is stable. And the temperature on the right is showing after change, where the temperature is increasing. So here we have the energy coming in is equal to the energy going out. Sometimes it just so happens that the energy coming in is greater than, it is more than the energy that is exiting the system. And we're going to learn that carbon dioxide and methane are two gases that create the situation because they don't let all the energy that would naturally be going reflecting back into space, it doesn't let it exit the system. Notice in the model above, after the change, which is the one on the right, the amount of energy going in is greater than the amount of energy going out because of the increased carbon dioxide. The amount of energy absorbed by Earth's surface has increased, shown by the yellow glow, which increases Earth's temperature. We've mentioned this yellow glow before here. This yellow glow is brighter than this one here. It's showing you the energy that is absorbed by Earth's surface. These little diamond shapes are showing you the amount of carbon dioxide in the atmosphere. So when there's more carbon dioxide than, say, here, carbon dioxide actually prevents some of that energy from exiting, and so more energy is absorbed by the Earth's surface. The same would be true if it was methane instead of carbon dioxide. So now it's time to copy and paste into your Unit 7 key concepts under Chapter 2. So key concept number 10 is, if there is an increase in the amount of carbon dioxide or methane, the amount of energy leaving the Earth's system decreases. So more energy enters than exits. So important key concept. I'm going to copy this. And I'm going to go to my key concepts document that I've been pasting in. And I'm going to paste key concept number 10 there. All right. You can pause the video if you need more time. The article also discussed the cryogenian period, otherwise known as snowball Earth. Let's read again the section that describes what Earth was like during this period. Snowball Earth, the cryogenian period. Let me close that. About 800 million years ago, Earth got much colder. Over time, ice covered most of Earth's surface, maybe even all of it. This was the cryogenian period. You may have heard of ice ages in Earth's past, but the cryogenian period was much colder than any ordinary ice age. During this period, the average global temperature may have fallen as low as negative 20 degrees Celsius, which is about negative 4 degrees Fahrenheit. Even the equator, before I say that, to give you some comparison, remember that water freezes at 0 degrees Celsius and at 32 degrees Fahrenheit. So negative 4 degrees Fahrenheit is actually about 36 degrees below zero. Below freezing. I shouldn't say below zero. 36 degrees below zero. So even the equator, which today is warm and tropical, experienced freezing temperatures back then. Nothing lived on land at that time. All life was in the ocean, in liquid water beneath the frozen surface. The only living things on Earth at the time were simple sponges, worms, and microscopic creatures such as bacteria and algae. During the cryogenian period, Earth's surface was an icy wasteland that scientists have nicknamed Snowball Earth. Lesson continues below. We have to put some space here to make things fit where we wanted them. So let's explore how Snowball Earth could have happened. Many of you know that lighter surfaces reflect light or heat energy. Darker objects absorb more light or heat energy. On Earth's surface, the white ice will reflect back more energy into the atmosphere than the darker ocean. So ice, because it is a lighter surface, it's kind of like glass, more energy gets reflected than the darker surfaces of water or land. So during this period, what changes caused temperature to decrease, making it colder on Earth? During the cryogenian, dust blocked sunlight, which decreased incoming energy, so less energy entered than exited. We're going back to that energy. Then ice increased, which made more reflection. This increased the energy leaving, and that made it even worse. So it was kind of a vicious cycle. They think that dust from outer space kind of blocked it. That's what the article had said on Friday. Had kind of the Earth went into its path, and some of it entered the atmosphere and blocked the sunlight. And so the energy coming into the system was less than normal. So it got cold. Ice was created. So energy that was coming through was being reflected back into space. So it got even colder, which made more ice. And it was kind of a vicious cycle. It just kept on going in a cycle. What is the connection between reflectivity, energy entering and exiting the Earth system, energy absorbed at the surface, and temperature? When energy reflects, like off ice, a lot of energy exits the Earth system without being absorbed. So when reflection increases, the flow of energy leaving also increases. This can make the system not stable, with more energy exiting than entering the system. This means there's less and less energy at the surface. Energy absorbed at the surface is what makes temperatures warmer. So if there's less energy getting absorbed there, temperatures get colder. Makes sense. All right, key concept number 11. Time to copy and paste into your Unit 7 key concepts under Chapter 2. Let me read this first. Key concept number 11, if there is a decrease in the amount of carbon dioxide or methane, the amount of energy leaving the system increases, so less energy enters than exits. Okay, so I'm going to copy key concept number 11, and I'm going to go to my key concepts document, and I'm going to paste just like that. Pause if you need more time. So this diagram here is showing that key concept. Our before picture, before change, the temperature is stable. we have a certain amount of carbon dioxide or methane in the atmosphere. And then in the after picture, which is on the right, there's less of those gas molecules. And we see that the change results in less energy entering, more energy exiting, which leads to it getting colder, as demonstrated by this thermostat right here. Right, so more energy is leaving. All right, so next we're going to watch a video about Snowball Earth.
When I first saw this product, I thought it looked kind of crazy. Didn't really understand what the benefits would be, but I had seen.
The Earth circles the Sun, but this orbit is unstable. Over hundreds of thousands of years, it changes, swinging the planet further out into space and pivoting on its axis. At the furthest point in its orbit, and with the northern hemisphere tilted away from the Sun, the Earth cools. 2.4 billion years ago, something turns this natural cooling into a global catastrophe. It is one of the most dangerous things in all the universe. Life. Tiny organisms populate the oceans. There's no oxygen around, and that's the way most of them like it. But then, a new kind of bacteria evolves. Cyanobacteria. And these guys create a serious gas problem.
Imagine Earth billions of years ago. There's no oxygen. Everybody's happy. Then cyanobacteria start making oxygen. It's a toxic pollutant. If there was a regulatory agency at the time, they would have been outlawed. Eventually, they polluted the whole world. They had really precipitated an ecological crisis of global proportions.
The great oxygen crisis upsets the greenhouse effect that keeps the planet warm. And with the Earth at its furthest point from the Sun, global temperatures plummet.
The ultimate culprit is biology. Biology makes a mess of the planet, produces oxygen. The oxygen destroys the greenhouse effect of methane, and that freezes up the Earth.
2.4 billion years ago, ice creeps out from the poles. Instead of warming the planet, sunlight bounces off the ice. Temperatures fall, creating more ice, which bounces more sunlight back into space, and so on, until the cooling becomes unstoppable. The ice marches on. Temperatures plunge to an average of minus 74 degrees. The blue planet turns white. It's a snowball Earth. And incredibly, this may have happened not once, but at least 3 times over the following billion years as the planet lurched around the Sun. But throughout all of this, and against all the odds, a handful of species clung to life. Thanks to volcanoes.
Even in an Earth that was covered almost entirely by ice, volcanoes would have been punching through that. So you'd certainly had pockets of water lying about. Then life was able to carry on and get through these cold periods.
And the whole time, the volcanoes that help sustain life have been pumping out carbon dioxide. As this greenhouse gas increases, the atmosphere warms, until 640 million years ago, the last great snowball Earth ends. And the survivors emerge into a new world.
Right. So going back to our document, please turn this assignment in when you are done. You didn't really have to type anything in, but it is important to go through the video. So if you don't turn that one in, it's no big deal. Do not turn in the key concepts assignment yet. You will continue to work on this assignment later. So do not turn in your key concepts assignment yet. You will continue to work on that. You can turn this one in or not. It's not for a grade, but it is important to go through the lessons because you guys are going to have that final exam that will be over the quarter for lessons and content. Okay, you guys have a good day. Bye.